Look at the current state of international trade, and you will see a global economy losing momentum. Ongoing conflicts are actively disrupting established supply chains, which in turn drags down industrial production and consumer spending. This slowdown is highly visible in Europe. Economic expansion across the euro area is currently forecasted to stay low, heavily constrained by a drop in external demand and the high cost of importing fossil fuels to power their industries. In China, economic growth is settling into a much more moderate trajectory as the government manages local debt risks and navigates severe property sector adjustments, deploying targeted fiscal measures to keep domestic consumption steady without triggering financial instability. At the same time, several emerging market economies are being squeezed by tighter global financing conditions. Currency depreciation is driving up debt service costs, forcing international financial organizations to step in with restructuring frameworks to prevent defaults. To survive these shifting tariff regulations and geopolitical risks, multinational corporations are rapidly restructuring their logistics networks. They are prioritizing regional manufacturing hubs to insulate themselves from future trade disruptions. Faced with these overlapping pressures, policymakers are largely paralyzed. Major central banks are keeping interest rates steady, unable to offer traditional economic stimulus without risking a renewed spike in consumer inflation. Yet, despite tightening credit conditions and a global manufacturing slowdown, the United States' gross domestic product continues to grow. That growth is being propped up by a massive influx of private sector investment into artificial intelligence. This chart maps that exact divergence. You can see traditional manufacturing output trailing off on one axis, while the other axis shows surging outlays in technology infrastructure, completely offsetting those broader economic losses. We see this playing out directly in the labor market. Job creation in advanced economies is normalizing because businesses are choosing to invest their capital in automation tools and operational efficiency, rather than expanding their human headcount. This shift relies heavily on edge computing, a silicon architecture designed to process data directly on connected local devices, instead of sending it back and forth to remote cloud servers. Major semiconductor labs are now dedicating entire facilities to building this energy-efficient hardware. Simultaneously, research laboratories are releasing foundational AI models with drastically improved reasoning capabilities. These upgrades allow developers to build highly complex applications using a fraction of the computational power previously required. Technology leaders are actively deploying these systems. At specialized forums in cities like Bengaluru, developers are focused on integrating agentic AI, multi-agent software designed to execute complex enterprise workflows completely independently. Artificial intelligence now operates as a load-bearing structural pillar of physical industry, sustaining production capacity through automated logic. But running this new automated infrastructure requires immense amounts of electricity. That energy demand exposes the technology sector to the exact same volatile crude oil and natural gas markets that are currently dragging down the broader economy. To hedge against that resource scarcity, industrial manufacturers are directing record amounts of private capital into long-term renewable energy contracts. Investments in grid modernization and clean technology have hit historic highs, despite global macroeconomic headwinds. This battery cross-section shows advances in energy storage. By altering internal materials, researchers tested prototypes increasing energy density while dropping charge times. Scaling these extends electric vehicle range, giving operators reliable ways to store excess renewable power for peak usage. Material science is also advancing the physical hardware. Engineers have engineered a novel 3D printed composite rubber with a unique granular architecture. It resists crack propagation and mechanical fatigue, allowing soft robotics to endure the stress of heavy industrial manufacturing. Maintaining the automated economy now requires a global green transition, framing sustainability as a mandatory engineering solution rather than a purely environmental choice. Operating an enterprise largely through autonomous software agents introduces a new layer of risk. Recent security evaluations show that when these systems execute tasks without human oversight, they develop unpredictable behaviors and expose new network vulnerabilities. To secure this highly automated infrastructure, global enterprises and governments are accelerating their migration to post-quantum cryptography standards. They are mandating stricter encryption compliance to protect critical data from future, highly advanced decryption techniques. This era of deep computational analysis is also accelerating biological research. Leading medical institutions have recently published clinical studies identifying specific microbial metabolites in the gut that directly connect to the progression of Alzheimer's disease. In reproductive health, pharmaceutical labs have cleared major preclinical milestones. Long-term animal studies have demonstrated a safe, non-hormonal method to temporarily interrupt sperm production, opening the door for reversible male contraception. The tools built to stabilize the industrial economy are now penetrating the microscale, isolating specific biological mechanisms and securing raw data at the foundational level. If you look strictly at the top-line economic headlines, the global system appears to be sputtering. But beneath that surface, private investment and technological capability are accelerating rapidly. The geopolitical frictions that disrupted global logistics and spiked energy costs did not stop progress. They acted as a pressure test. They forced corporations to abandon vulnerable legacy systems and fund highly efficient automation. We are watching the real-time integration of different scientific fields. Advanced cryptography secures the data. Autonomous agents process the workflows. Custom materials execute the physical labor, and renewable grids power the loop. By colliding slowing macroeconomics with rapid technological breakthroughs, these forces are engineering a decentralized, highly resilient industrial base built to withstand the geopolitical shocks of the future.